The broadcast is now starting. All attendees are in listen-only mode.
Welcome to today's Clean Cities webinar. I'm Sandra Loy from the National Renewable Energy Laboratory. Today's webinar will highlight the Clean Cities CNG Fuel Tank Safety Initiative, which helps fleets to understand tank inspection and end-of-life requirements, including safely defueling, decommissioning, and disposing of expired tanks. Vehicles using CNG fuel systems require different maintenance and inspection than conventional fuel systems, which is why this new safety initiative has been developed. Today we have two experts from NREL, Kay Kelly, Project Leader, and John Gonzalez, Senior Engineer, who will talk through considerations surrounding this topic and answer any questions you may have. Before we get started and I pass things over to Kay to kick off the webinar, I'd like to go over a few items so you know how to participate in today's webinar. As noted at the start of the webinar, all attendees are in listen-only mode and will remain so through the entirety of the webinar. When you logged into today's webinar, by default, you will be set to listen in using your computer's speaker system. If you'd prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. We are recording today's webinar and it will be posted on the Clean Cities website within the next 10 days. We will be hosting a question and answer session at the conclusion of the presentation. We encourage you to submit questions as the presentation is taking place. You can do so by typing your questions into the questions pane of your control panel. We will collect these and address them during the question and answer session. Before we begin, I'd like to find out how you heard about today's webinar. Please respond via the poll you'll see on your screen. Please select the appropriate response and click submit. I'll give everyone a minute or so to respond. Okay, just give it another second. Anyone else? Okay, I'm going to go ahead and close the poll. Thank you all for participating in that poll with us. So without further ado, I'd like to pass things over to Kay Kelly. Kay, you may begin.
Thank you, Sandra. So today, slides appear to be stuck. There we go. So today we're going to start with some CNG basics and background on how the CNG safety project came to be. We'll provide an overview of the applicable codes and requirements pertaining to CNG vehicles and their fuel tanks. We'll introduce the CNG defueling, decommissioning, and disposal video that was developed by the Clean Cities program to assist fleets with expiring tanks. And we'll also preview some of the other topics under the CNG Safety Assurance Project umbrella that are underway. And then we'll, as Sandra said, we'll close with a Q&A session. So when we looked at the list of registrants for the webinar, we noticed we had a very diverse list of participants. So bear with us. We are going to dedicate a couple of quick slides at the beginning to the basics to make sure that we've got everyone on the same page. So natural gas is a mixture of hydrocarbons, predominantly methane or CH4. And interest in natural gas as an alternative fuel for transportation stems from the fact that it is a clean burning fuel. It has a domestic resource base and it is widely available commercially. Compressed natural gas CNG and liquefied natural gas LNG have been used for decades to fuel light duty and heavy duty vehicles. So it has been in the market for a while. Natural gas has a high octane rating. It has excellent properties for spark ignited internal combustion engines. It's also non-toxic, non-corrosive, non-carcinogenic, and it doesn't present any threats to soil, surface water, or groundwater. Conventional natural gas is primarily extracted from gas and oil wells, although small amounts of natural gas are considered renewable natural gas. And to explain this in a very simplistic manner, as organic matter such as sewage or animal byproducts agricultural, municipal solid waste decompose, natural gas is produced, and that gas can be captured and distributed as renewable natural gas. Most commonly, this is a process that happens at landfills and livestock operations, and there are small amounts of these operations available today, and that number is growing. More projects keep coming online all the time for renewable natural gas. So natural gas does account for approximately 1/4 of the energy used in the United States. It's used for residential, commercial, industrial purposes, as well as for electricity generation, but only about 0.1% is currently used as a transportation fuel. As I mentioned, it's widely available. There's a vast pipeline system which can quickly distribute natural gas just about anywhere in the lower 48 states. Because this fuel is a gas, it is stored on board a vehicle in either compressed gaseous or liquefied state. Compressed natural gas, or CNG, and liquefied natural gas, LNG, are both considered alternative fuels under the Energy Policy Act of 1992. The information we discussed today is primarily focused on CNG, but LNG is mentioned here to differentiate between the two. So CNG, a CNG-powered vehicle does get about the same fuel economy as a conventional gasoline vehicle on a gasoline gallon equivalent, or GGE, basis. And liquefied natural gas, in order to store more energy on board the vehicle in a smaller volume, the gas is liquefied, and 1 GGE equals about 1.5 gallons of LNG. But because it must be kept at such cold temperatures, LNG is stored in a slightly different vessel than CNG. It's stored in a double-wall, vacuum-insulated pressure vessel. And these LNG fuel systems are typically only used in heavy-duty vehicles that travel pretty long distances and need to carry a lot of fuel on board. Most natural gas fueling stations dispense CNG, which is either compressed on site or compressed off site and transported to the station in tanks. And the availability of LNG is mostly around trucking corridors, again, because the heavy-duty vehicles are the typical users of that fuel. In terms of vehicle applications, a significant number of natural gas vehicles are on the roads. There's a wide selection of vehicles available from original equipment manufacturers, conversion companies, and installers that perform conversions. If you do have a conversion, a reminder that they should be approved by EPA or CARB, depending on which state you operate those vehicles in. OEMs have a variety of light-duty options, including pickup trucks, vans, and passenger cars. There are also a lot of medium-duty vehicles and shuttle bus applications, work truck applications like short haul or delivery. A lot of CNG school buses on the road. Really big markets for natural gas include refuse trucks. It's estimated that more than half of new refuse trucks purchased are natural gas vehicles. And also transit. Natural gas has been used in transit for many years, many decades. And about 19% of all transit buses in service do use natural gas. So a significant number of these vehicles are on the road, and they're equipped with CNG fuel tanks or cylinders that were manufactured sometimes in the 90s, early 2000s. And more recently, we've seen a lot of Class 8 trucks and other vehicles gaining popularity across the U.S. And a great number of these tanks are approaching the end of their service life, which brings us to the CNG Safety Assurance Project, which is the focus of our webinar today. So with so many natural gas vehicles on the road in the U.S. and internationally, and with those numbers continuing to grow, there's a natural focus on the ongoing safe operation of these vehicles. The natural gas industry has traditionally been very risk averse, and thankfully there have not been many safety incidents to speak of, and everyone wants that track record of safety to continue. The industry meets regularly to discuss concerns, to thoroughly evaluate any incidents that do occur, and to discuss and anticipate any potential problems so that they can prevent incidents from happening at all. So natural gas fuel tanks do have a limited lifespan, either 15, 20, or 25 years. And in some applications, the vehicle can outlive the CNG fuel tank that it's equipped with. And note that throughout the webinar, we're going to use the term tank although many of you will also call this a CNG fuel cylinder. They mean the same thing. So aging CNG tanks has been a topic of conversation at the Natural Gas Vehicle Technology Forum, as more of these vehicles have been on the road and whose tanks are approaching or have even reached the end of their life. The Clean Cities program runs a technical assistance program for fleets, and we received a call from a transit agency a couple years ago seeking assistance with a large number of CNG tanks that were approaching their expiration. Keep in mind that transit buses traditionally have 6 to 8 tanks per bus, and transit agencies tend to purchase dozens or even hundreds of buses at a time. So all totaled, this particular transit agency had 160 buses and more than 1,100 tanks that were going to expire in short order. And they wanted to be sure that they were handling them appropriately. And they weren't finding many resources out there to help them with that task that they were facing. As we assisted this transit agency, we looked at the adoption curve for natural gas vehicles nationwide and recognized that many other fleets would soon be facing the same problem with tanks expiring. So we decided that it would be a good opportunity to use this particular fleet's experience as a case study that we could use to help others when their tanks did start to expire. So over the course of the past couple of years, the U.S. Department of Energy and the National Renewable Energy Lab have taken the lead to put together a government industry partnership that's providing resources related to training, best practices, case studies, and generally outreach and awareness to ensure that these vehicles continue to be operated safely and that fuel tanks are decommissioned appropriately at the end of life. And the webinar today is part of that effort. So with that, let's talk a little bit about tank safety. Here you can see CNG tanks on 3 different vehicles: a Ford Transit Connect CNG taxi, a refuse truck, and a long-haul truck. Like any fuel, natural gas is flammable, so the fuel storage and delivery systems for natural gas vehicles are governed by the National Fire Protection Association codes, or NFPA. So NFPA 52 is the Vehicular Gaseous Fuel Systems Code. That spells out the specific safety requirements for NGVs and their fueling facilities. In addition, NFPA 30A applies to facilities that perform maintenance and repair of natural gas vehicles. And there's also NFPA 88A that applies to parking garages where natural gas vehicles can also reside. I'm now going to hand things over to my colleague John, who's going to get into some more specifics on the code requirements.
Thank you, Kay. In the case of natural gas vehicles and natural gas conversions primarily, the codes that are followed for those are NFPA 52. You will also see FMVSS 49 as another code that is looked at. But in this picture, one of the evident things as far as inspections when you look at a vehicle or when they're looked at are some of the telltale signs that there's something not correct. And the upper right-hand corner of that picture is a fuel line that is not vapor protected. So if this vehicle were to have a leak, it could leak into the passenger compartment. So that's one of the pieces here. The second piece is you can see where that lower circle is, but below that is the bracket that attaches this tank itself to the vehicle. It is not attached securely. In NFPA, it does call out how that needs to take place, and this could create an accident waiting to happen in a vehicle. If this were rear-ended, this tank could come out and could create a lot of problems. So this is one of the key things as far as when vehicles are being initially converted and when people inspect them, that they're looking for these things. But another part of the code, part of NGV2 along with FMVSS 304, is the vehicle needs to be inspected every 3 years or 36,000 miles. And also it needs to be the tanks themselves, if the dispenser that is dispensing the vehicle the fuel has a malfunction and is filled over 125% of its rated fill pressure, the fuel tank needs to be removed from service. That means if it's filled at over 4,500 pounds in a 3,600 pound vehicle, the fuel tank needs to be removed from service. This next slide is some pictures of an incident that occurred last summer. You'll see on the far upper left is how the truck is supposed to look, and you will see on the upper right what happened when the fuel tank in the bottom picture ruptured. What happened in this incident was This truck was driving down the highway. It was pretty low on fuel. It was not far from its destination, and it hit a piece of road debris. The road debris caused damage to the fuel tank, but the tank itself maintained its integrity. At that point, then the truck went to its fuel site. It inspected the truck. He believed it was okay to fuel, didn't see any real damage to the fuel tank. He started fueling the tank at about, probably we believe, about 1,400 or 1,500 psi. The tank then ruptured and created the damage you see to the truck. This has now created a new protocol for this company. If the driver does believe, and through this incident investigation we did, and we recommend folks, if the driver does suspect the tank has been damaged, anything has been compromised, pull the vehicle over, take it out of service until somebody inspects it. Make sure, once again, that the vehicle is intact and the tank is intact so no issues arise from an incident like this. The next here is just a slide that shows kind of what the requirements are for the fuel tanks themselves. You will always see a date of manufacturer. You will also see a do not use after date that is critical to find on here. Some other things you'll find in the US is you will find a tag that says FMVSS 304, and preferably we want to see NGV2 standards that this tank meets those qualifications. Those are critical. Tank life ranges from 15, 20 to 25 years, and it is per manufacturer recommendation, per code, that once they reach their end of life date, the fuel tank needs to be removed from service and destroyed. It cannot be, at this current date, recertified and brought back into service.
All right, so I'll take back over for a little bit here. So as I mentioned before, we did have the inquiry from the transit agency on how to deal with all their expiring tanks. And we wanted to assist not only them, but anyone else who was dealing with this problem. So we decided that our technical team would develop some public education materials on how to safely defuel, decommission, and dispose of a natural gas fuel tank at end of life. We called a number of transit agencies using natural gas for their buses, and we happened to call Los Angeles Metropolitan Transit Agency at a time when they were in the process of decommissioning a large number of CNG tanks in their fleet. They invited us out to observe what they were doing. So we went out there, a team from the U.S. Department of Energy, from the U.S. Department of Transportation, CSA Group, Agility Fuel Systems, Gladstein, Neandros and Associates. We took a whole team of folks out there and basically walked around the garage for a couple days, observed and documented their procedure, and took some video as well. So the video that we took there and the notes and everything have been turned into a training video that's now available on our website. So the video we developed is 15 minutes in length. It's available in both the full-length format to watch beginning to end, and also as 4 individual chapters. You can find the video at a couple different places on our website. If you're familiar with the Clean Cities website, cleancities.energy.gov, you can go to the news and events section, and there's a blog post on it that describes the tank initiative and links to all the various links and editing of the video. You can also access the full video directly from our YouTube channel, and that link is at the bottom. Don't worry, you don't have to be scribbling that down. We are going to send that out to you after the webinar. And since long video segments can sometimes be problematic over a webinar, we won't be showing the actual video today. We're going to go over the basic outline of the defueling, decommissioning, and disposal chapters, but we definitely encourage you to view the actual video once the webinar concludes at your convenience. So with that, I'll hand it back to John, and he's going to go over defueling, decommissioning, and disposal.
Thank you, Kay. This is kind of getting into some of the meat of the program, is the defueling and the defueling as far as how you take the fuel out of the vehicle. What we want to do is make sure people are going through the approved process. A lot of times the manufacturer will have this set forward, so that's why we put on there real critically, follow manufacturer's guidelines. Also train the technicians. Make sure they've gone through all the proper training to do this, because it is critical. It is a high pressure gas, so you want to make sure you're doing that. And then before you start providing this service and providing the defueling of the vehicle, you want to make sure you inspect all the hardware, tanks, valves, fittings, make sure there's no damage. So you're working with a system that has its integrity intact. And also, the critical piece is we have found that you want to try to defuel the tank while it's still intact in the vehicle. Do not remove a fuel tank that is full, because at that point you can risk dropping the tank and having an issue. Another critical piece is earth ground the vehicle. Make sure that tank itself is earth grounded as well. Sometimes the tanks will have straps and they will not be earth grounded at that point, so you want to earth ground the vehicle and also earth ground that tank as well, so you don't create any static electricity. The next thing is, this can take a little while. Just be prepared. It can take from 1 to 12 hours depending on the size of tank and depending on the configuration of the fuel tank. So make sure to put some time aside to do this. Also, check the system with a pressure gauge. Make sure you have an accurate pressure gauge, and it is critical to note where your pressure began and where you ended, so you don't have any concerns about that you did vent the fuel from the fuel tank itself. And also make sure you vent any residual gas remaining in the tank, and that could be used through the vent stack, which we'll talk about here shortly. But make sure that all is removed, because sometimes in the next procedure we talk about defueling to another vehicle, it doesn't pull that gas all the way down. Finally, you'll see here, and we'll continue to go through this, verify and document the process fully and completely. Because the one thing we know is, unfortunately, sometimes we get busy and we might miss a step. And if we don't document it, we don't know that step's been missed. So verify and document completely that the defueling has taken place. Some of the common defueling methods or options there are is the preferred method is really defueling to another vehicle. And this can be done vehicle to vehicle. This becomes what they call a pressure equalization. That will only bring it down to half or whatever that vehicle that is receiving it. The next is defueling it to storage. This here is where a lot of new stations are beginning to be designed this way, to where a vehicle can be hooked up to it. The compressor, in fact, will start up and use the gas from the vehicle to recompress and deliver it to the storage system or to a new vehicle. This has the ability to bring the vehicle pressure down to roughly whatever inlet pressure is for that station, can be down to 20 pounds or down to 100 psi, but can remove all that fuel and put it into another vehicle, and we don't have to worry about venting it to the atmosphere. The next is a vent stack. This has been the common method, which is the center slide you'll see to the left. That stack that's there is vented to atmosphere. We're, as an industry, trying to get away from this. It is approved, but we are definitely trying to get away from it because we are venting methane to the atmosphere. And then the final is the flare stacks. This is pretty new to the industry, and it really becomes dependent on your location and also fire jurisdiction if they will allow you to do this. This will allow you to vent and burn the gas to the atmosphere. Once again, there are a lot of codes that are stipulated with that, so work with your AHJ to get the approval on that. But these are the common defueling options that you have available to you. And then once again, in the defueling process, verify that it is completed. Verify this with a fuel gauge. Make sure that you have all that fuel removed. If it's down to the residual, down to the 100 psi, and you don't have a way to vent it to that vent stack, be safe, but verify that that pressure is down that low. Make sure you're wearing protective equipment, safety glasses. Also, as you can see, this gentleman in the upper right-hand corner, he is on the top of a transit bus. He has all the safety harnesses in place to ensure that he will not slip or fall from this vehicle. You can also see the different safety harness holding the fuel tank as well, making sure that there is nothing that tank cannot fall from that vehicle. Disconnect all the fuel lines before removing the valve. Once again, we've ensured that the pressure is low. We've now vented this to a vent stack, and now we know we have no gas in and we can remove the valve. Remove the tank from the vehicle itself. Traditionally, you like to remove the tank in the vehicle because the vehicle is secured and it's easier to remove that tank at that point and that tank valve. Remove the mounting brackets and then just remove that tank. The next piece is to purge the fuel tank itself. You want to purge the tank with nitrogen. Never, ever, ever use shop air to purge the tank, because if you do that, you can create a combustible mixture. Always use nitrogen, which is an inert gas. Make sure you remove the fuel that way, any residual fuel that way. Drill half-inch holes, like you see the gentleman there on the bottom picture, bottom right, ensuring that this fuel tank can never be filled again. And then label the tank, mark where those holes are, saying these are holes, tank not to be used again. Once again, verified document that you've done all these processes, so anybody that might come across this fuel tank knows everything has been done correctly. Then the final piece is the disposal of the fuel tank. This becomes a little bit of a challenge because we would love to find a way to recycle these tanks. In some cases you can, if it's a type 1 where it's all steel, or if it's a type 2 where you have a steel liner or aluminum liner, you can recycle those components. Type 3s and type 4s are a little bit more difficult because there really isn't a great medium to recycle these type 4s, which is what you see in this picture here. A type 3, it's difficult to get the overwrap off the aluminum on a type 3 liner type tank. So what we do is we ask you to follow the recommended procedures by the manufacturer on how to do this. And as you can also see in that video or that picture there, the gentleman's moving that pallet of tanks. That yellow mark there shows where the holes were drilling and how the tanks are not to be used again. Also in this picture here, you will see that the tank valves have been removed, so that vehicle or that fuel tank cannot be fueled anymore either.
Thanks, John. So before we move on from defueling, decommissioning, and disposal, I also wanted to point out another resource from our colleagues at CSA Group. CSA has an express document, EXP 2.1. It's called the Best Practices for Defueling, Decommissioning, and Disposal of Compressed Natural Gas Fuel Containers, also referred to as the 3Ds. And note that express documents are the first step toward putting something into code, so know that this is moving in that direction. It's currently an express document, but it is anticipated that it will move into code. There's also work underway to do a 3Ds document for LNG and for hydrogen containers, so that this procedure is covered in code for all for more than just one fuel type. We visited LAMTA in December 2015, and that was right about the same time that CSA was starting their express document process. And we did have a representative from CSA on our site visit to LAMTA. In addition, both John and I served on the CSA committee that developed this express document. So you will find common language, and you will find the procedure to be consistent between the Clean Cities video and the CSA document. And both the CSA document and our video were released in September 2016. So if you're looking for the written procedure, you will find it in the CSA document in great detail, and it is available on CSA's website, csagroup.org. As we near the close of the presentation, I wanted to take a moment to preview some additional CNG safety assurance efforts that are in progress. The first is an end-of-life CNG tank testing effort. We have evidence that people are keeping tanks in use beyond their expiration date. This is certainly against manufacturer recommendations and against codes, but it is happening nonetheless. Because it is happening, our team is interested in assessing the risk involved with this practice. So we are in the process of evaluating a cross-section of CNG fuel tanks that are leaving service. And the results of this testing will be shared with industry in the near future to continue to validate and improve tank safety standards. Secondly, we are continuing to work hand in hand with NHTSA, CSA, and industry to investigate incidents involving CNG vehicles. This involves both determining the root cause of that incident and disseminating best practices to others in an effort to prevent future similar incidents. The example John discussed earlier really highlights how this works. After that incident with that particular truck, the fleet instituted a policy that anytime a driver thinks the tank could be damaged, they call and have the vehicle towed for inspection. They indicated it's just not worth the expense compared to the potential incident if that tank is compromised. And it's important for our team to get the word out to other fleets so that they can take similar precautions and make sure something similar doesn't happen. Finally, we're also looking at the maintenance facility side of things. We've been hearing from fleet managers for many years that they want more information on the modifications that they need to make to their maintenance facilities in order to service natural gas vehicles. So we're getting very close to publishing a handbook for that audience. The handbook will describe how natural gas behaves differently from gasoline or diesel in the maintenance facility environment. It'll highlight which building systems need to be evaluated for compatibility with natural gas and how projects like this typically proceed. Another aspect of the maintenance facility modification work is the fact that building codes that address unintended indoor releases of natural gas from vehicles were developed before a lot of these vehicles were in service, and honestly, they were developed in a largely theoretical manner. People thought the gas would behave in a certain way, and codes were developed based on that prediction. Our colleagues at Sandia National Lab are developing some modeling tools to validate the existing codes based on how CNG actually behaves during an unintended indoor release. And again, the results of that testing may influence future building codes. So as these various work products develop, we will plan to hold additional webinars that provide more information. In the meantime, we encourage you to visit our Alternative Fuels Data Center website for the most up-to-date information. We have extensive resources available on CNG fuel, infrastructure, vehicles, maintenance, and safety. So if you go to afdc.energy.gov, you can select natural gas on the homepage, and you'll see a whole menu of things in the left-hand column that you can get more information about. Much of what we discussed today can be found under the Vehicle Maintenance and Safety heading. So if you have any questions about what we've covered today, this is our contact information. Feel free to reach out to us at any time, and we'd be happy to help. Note that two things will happen after today's webinar. First, you'll get an email with links to the video so that you can view the video in its entirety at your convenience. And also, in about a week or so, we'll post the webinar recording to the Clean Cities website, and we'll send you another email once it's posted. And that brings us to our Q&A session. So if you have a question, we welcome your questions. If you have a question, you can type it into the question pane on the control panel. And Sandra, do we have any questions that have come in so far?
Nope, not at the moment, but we'll give everyone a minute to go ahead and type in your questions. Thank you both to Kay and John for the presentation today. Some really great information. And if you do have any questions, you can reach out to Kay, John, or myself. But go ahead, don't be shy. If you have any questions, now is your time. Go ahead and type it into the questions pane in your control panel. We'll give everyone a minute. So we just received a question about whether we will be making the presentation itself available, and I'm assuming yes. In addition to the recording, we'll also post the PowerPoint in the same place. So yes, you will have access to both, and when we send out the follow-up, we will include the link where you will find both the PowerPoint and the recording. I have a question that came in here. Do electronic gas detectors fit into your programs?
Talk about the maintenance agreement, the maintenance document.
Yeah, so we do address the various types of gas detectors for maintenance facilities in our facility modifications handbook. The handbook describes all the various building systems that need to be reviewed and possibly modified, and we do talk about different types of gas detectors in that document.
And we're in the final stages before the release of that document.
Yeah, we expect that that'll be ready sometime this summer, hopefully a little sooner, but this summer for sure.
So just adding on, I think, to that electronic gas detector question, handheld?
You can use handheld. That would be for vehicles too.
Okay.
When you want to check to find out if you have a leak on a vehicle, there's also another method is leak soap detection. You can do both ways. There's two ways to do it when you want to check to see if you have a leak on a vehicle.
Okay, great. Couple questions coming in. How do you inspect steel tank interior for rust?
There is no means to inspect the interior of a tank through its 15-year life. That would require removing the valve to do that inspection. It is not called in code that you have to do that. And we have to say we've been fortunate in the industry. We have not had that as a problem in natural gas and natural gas fuel tanks.
Okay, great. Another question here. If a vehicle is being decommissioned and sold, possibly to a private party, but the tanks are not at the end of useful life, is it recommended that the tanks be decommissioned before sale?
So if tanks are, so if you are selling a vehicle and the tanks are near the end of their useful life, we do recommend that you perform a safety inspection on those tanks and provide all of your safety inspection records throughout the course of that vehicle's life to the new owner. We've also heard that it is a best practice to draft up a document stating that you are selling a vehicle and the tanks are expiring in, 6 months or a year, to actually note that on a document that you provide to the purchaser that recognizes the tanks were in good repair when you sold the vehicle, and the responsibility to continue maintaining, inspecting, and eventually disposing of that container is transferring to the new owner along with the vehicle title itself.
Okay, great. So this is more of a comment, and maybe you'll want to add to it, but someone commented, it seems the tank life for steel, aluminum, and fiber will have very different fatigue life.
They all are designed to the same standard, either NGV2 or FMVSS 304. So really, not really. They meet a standard, and they are designed for that 15, 20, or 25-year life. So no, there really isn't a different fatigue factor depending on the material that the fuel tank is made from.
Okay, good. So, Kay, I think you already mentioned this, but a question again, or reminder on when the handbook, I believe it's the facility document that's being referenced for fleet managers, when will that be available, and how will folks be notified of its availability?
So it's working our way through the publication process. We do anticipate that it will be issued sometime this summer, and we will advertise its availability to the Clean Cities Network and with our industry partners. So chances are, if you heard about this webinar, you will hear about the Facility Modifications Guide through that same channel that you heard about this webinar. And we will also plan to do a webinar when the document is released to go through some of the highlights of that to help you understand it and use it.
Great. Another question, so related to tank weight, assuming the same size, is there a significant difference in weight based on composition of the tank?
Yes, there is. It's considerably it's kind of think about numbers going 1 through 4, 1 being the heaviest, 4 being the lightest, 4 being full carbon fiber, overwrap, and then 1 being all steel, so they would be the heaviest. So yes, type 1 is the heaviest, and it gets lighter as type 2, type 3, and then type 4.
And there is a difference between the size of a light-duty tank versus a heavy-duty tank. So tank size does also play a factor in that. But material-wise, the type 1s are.
Correct.
Okay. I'm not seeing any new questions on here. I don't know if either of you had any additional comments or thoughts you wanted to add.
I think I just want to add back to that structural piece. The fuel tank is designed to meet the application of 15, 20, or 25 years safely by design, whether it be a 1 through a 4. So material does not matter in that case. Are there different embrittlement characteristics of different metals over time? You bet. But the tanks are designed to meet a margin of safety through that design life.
Okay, well, thank you everyone. Not seeing any additional questions. So thank you all for participating on today's webinar. We will send out those follow-up emails with a link to the video as well as the link to today's webinar, in addition to a copy of the PowerPoint slides. If you have any additional questions, do not hesitate to reach out to any of us, Kay, John, or myself here at NREL and for Clean Cities. So thank you all for taking time to be with us today, and have a great week.